I am Joann DiGennaro, President of the Center for Excellence in Education. I co-founded this organization with the late Admiral H.G. Rickover, and I can't tell you how proud I know he must be, and I am, that you have participated in the USABO. I know that you've grown in your understanding of concepts, your ability to analyze data, and in your depth and breadth of knowledge in bio-based subject areas. I hope this experience propels you to further inquiry and that you have been strengthened in your desire to pursue a bio-based scientific career. The biofinals is the gold standard in biology. Now, you will participate in the gold activities of the Rickoid family. Rickoid, of course, named after the Admiral. You can participate in upcoming webinars, scheduled alumni events. Of course, you will receive recommendations to the colleges and universities of your choice. There will be invitations to very special CEE events, and I surely hope that we will have the holiday party at my home in person, and that I am not told that it should be virtual again this year in December. The camaraderie of alumni and your involvement of CEE begins this evening. You've participated in the USABO, and you certainly can participate as an alum, as a speaker, a member of the faculty of next year's Biolympiad, and to speak at our teacher enrichment program, to participate in the alumni funding campaign each year. And we even have a parents group. Maybe you can persuade your parents to become involved with CEE in welcoming the parents of alumni of our programs and speak about activities and things that we should pursue in the future for our alums. This evening, it is my great pleasure and honor to introduce Dr. Robert Lefkowitz. He is a Howard Hughes Medical Institute investigator who has spent 48 years of his research career at Duke University's Medical Center. Dr. Lefkowitz was awarded the Nobel Prize in Chemistry in 2012 for research on G-protein coupled receptors. The esteemed professor is in biochemistry and chemistry and a James B. Duke Professor of Medicine. He is a basic research cardiologist at the Duke Heart Center. He's been an investigator at the Howard Hughes Medical Institute since 1976 and is a member of the USA National Academy of Sciences, Medicine and Inventors, and the American Academy of Arts and Sciences. He has received awards such as the National Medal of Science, the Shaw Prize in Life Science and Medicine, and the Canada Gardner International Award, among many other accolades he justly deserves. Dr. Lefkowitz took of his very busy schedule to speak with you this evening. No surprise, because he has championed young scholars in science for many years to pursue their dream in science and technology. CEE is so gratified that he took of his valuable time to be with us and to speak with you young scholars. It is not often that Nobel laureates take of their time for this endeavor, and golly, do we appreciate it. Thank you, Dr. Lefkowitz. The floor is yours.
Thank you very much for that very kind introduction. Delighted to be with you today. I mean, I can just feel all that brain power radiating out from the screen. It's a pleasure to meet all of you. I've titled my talk today, A Tale of Two Callings. And I think most of you, I hope, have a sense of the meaning of the word calling. I think by calling, we refer to a certain deep sense that one is intended to do something, not necessarily based on logical reasoning, but just a feeling that you were meant to do something. And I think we generally tend to associate the term calling with people who feel a calling to the clergy, but you can feel a calling to almost anything. I actually have felt a calling twice in my life, and I suspect a number of you know what I'm talking about as well. The first calling I experienced was to medicine. Now, it was not, as suggested by this photograph, a calling to become a New York Yankees star player, although I'm sure that did cross my mind. But I show this picture simply to say that by age 6, 7, 8, or whatever I am in this photograph, I already knew that I wanted to emulate my family physician, Dr. Fibush, who made house calls in the Bronx. It just seemed to me like the coolest thing. He had this black bag out of which he produced all manner of magical things, a stethoscope, a reflex hammer, an otoscope, a prescription pad. And then he had all this special knowledge that allowed him to sort of lay on hands and make people feel better. So as I say, by this age, I already was convinced I would become a physician. I never wavered from that desire. I went to the Bronx High School of Science, a special school for gifted and talented that is admission only by competitive examination. Then on to Columbia College and Columbia Medical School. In college, I majored in chemistry. I loved medical school. It was the favorite part of my education, I suspect because I had dreamed of it for so long. Interestingly, unlike I'm sure many of you, I did absolutely no research in either high school, college, or medical school. Even though I loved science, I loved learning it, but I didn't love doing it. This is me with my parents. My dad, shown here, would die at the, to me, young age of 63, just 2 years later, after his fourth heart attack, his fourth myocardial infarction. I was an only child, and that was devastating to me. At my graduation, my dad told me, quote, "This is the proudest day of my life, seeing you graduate from medical school." I've often wondered to myself what he might have thought had he seen what came later. From medical school at Columbia, I stayed on. That's me as a medical intern with some of my intern group, and then a junior residency. And I think I would have very happily gone on to become a practicing physician. But fate intervened in the form of the Vietnam War. Now, this was a very, very unpopular war, which was peaking right around the time that I graduated medical school. There were demonstrations, even riots. There was a lottery draft for all men over 18, who were then shipped off to Vietnam, the war theater. But for physicians, there was no lottery draft. There was a doctor draft. Following your internship or a period of residency training, doctors were inducted for 2 years of service in the armed forces, potentially disrupting their plans to begin clinical residency or continued education and training toward a research career. Now, you could join the Army, the Navy, the Air Force, or the United States Public Health Service. Everybody wanted to join the United States Public Health Service. And the reason was that they had many bases that you could be assigned to here in the United States, such as the National Institutes of Health, NIH, the CDC that we hear so much about. And if you could get those commissions as a lieutenant commander, as shown by this officer here, then you could stay in the United States and not be shipped off to the war theater. So absolutely everybody wanted these commissions. It was extremely difficult to get them. Only the best and the brightest succeeded. I was fortunate. I was always the top of my class. And so I was, in 1966, when I graduated medical school, I was drafted into the public health service, given 2 more years for internship and residency, and then sent to the National Institutes of Health. Now, unlike this classy-looking officer, we did not wear uniforms. We wore white coats. We split our time about 80% on the wards, taking care of patients who were there for clinical research, and about 80% of our time learning how to do bench research with mentors in the wet laboratory. For the first time in my life, I met with sustained failure. I had never really met with any kind of sustained failure at any point in my career up to this. This is me sitting right here. So this was kind of a shock for me. I got depressed. My dad passed away 6 months after I got there. And the combination of the unremitting failure in the laboratory and his death really threw me into a spiral. And for the first year, I really succeeded in getting very little done. But during the second year, I began to meet with some success. And finally, toward the end of my 2-year hitch, I published my very first scientific papers. Was kind of excited about that. But despite the entreaties of my 2 mentors to stay on for an additional period of time to bring the research even further, I wasn't that enthralled with it. And so I decided to finish my clinical training and went up to the Massachusetts General Hospital, the main teaching hospital of Harvard Medical School in Boston, to complete my residency in medicine and then 2 years of cardiology fellowship. That shows me, as I looked in the early 70s up in Boston, pretty wide ties in those days, as you can see, and I have a beard for the only time in my life. It was there at the Mass General that I can say that I truly had my epiphany. And what I mean by that is when I went up there, I was not at all sure what role, if any, the laboratory would play in my long-term career. I knew that I wanted to do clinical medicine, and now I was kind of thinking about research, but I wasn't convinced. Anyway, the first 6 months, I dove in, loved it, was doing very, very intense clinical work, all clinical work. But toward the end of that first 6 months, I began to be aware of sort of a vague discomfiture. Something seemed to be missing from my daily existence. And after some soul searching, I realized that what I was missing was the stimulation and the creativity of the laboratory and trying to solve a basic laboratory problem and come up with something new rather than just sort of doing things the way you were supposed to, just sort of using the standard of care as we did in the clinics. And so then began the awakenings of my second calling to a research career. So I went into a research laboratory. I found myself another mentor. And for my last 2 years in Boston, I split my time between finishing my clinical training and working on a research project. And then in 1973, I was recruited to Duke, where in my first few years, I split my time about 40% on the wards, teaching medical students, residents, etc., internal medicine and cardiology, and maybe 60% in the laboratory, getting my research program started. Now, that changed fairly rapidly because within a year, we began to make significant discoveries, one after the other. And without necessarily making the actual choice, I found myself spending more and more of my time in the laboratory, so that within 3 or 4 years, I was probably spending 80 or 90% of my time in the lab and only 10% in the clinics. That continued for many years, for 30 or 35 years. And then about 10 years ago, I finally hung up my stethoscope for good. And now I spend all my time in the laboratory with my students and fellows. So what was I doing all these years? And why did I win the Nobel Prize? Well, the problem that I chose was trying to understand how hormones and drugs in the blood cause changes inside of cells. And I chose as my model system to study this very general problem, adrenaline. So we all know from our biology that adrenaline stimulates, amongst other things, the heart to contract more rapidly and more strongly. It stimulates the smooth muscle in airways to dilate so that you can treat an asthmatic in that way. But nobody really knew how something like adrenaline works. And in particular, the question, which was much more general, is how does a molecule like adrenaline or any other molecule like histamine, serotonin, dopamine, whatever, how does it know which cells to work on and which cells not to work on? And so I had the relatively simple-minded idea that there must be sites on the outside of cells that a molecule like adrenaline could bind to and fit into, much like a key fits into a lock. So in this analogy, the adrenaline would be the key, and that binding site on the surface of the cell would be the lock. And for years, pharmacologists had referred to such imaginary locks as receptors, but there was absolutely no evidence that they really existed. And for that matter, there was no way to study them or even prove that they existed. And so I set out using adrenaline to see if I could prove that there was such a thing as receptors, and then if I could, to figure out what they were and how they worked. And I was ultimately successful. This was decades of work, but I developed all sorts of new techniques that didn't exist, which allowed me to use radioactively labeled forms of adrenaline or other molecules, and to actually physically bind them, stick them into these locks called the receptors, and then to isolate the combination of the adrenaline or the adrenaline-like molecule with its receptor, to isolate it, to solubilize it out of the plasma membrane where it existed, and to really figure out what it was all about. And it's worth pointing out that there are two types of molecules that could fit into a receptor like this. One is what we call an agonist. It stimulates something. Adrenaline stimulates cells through its receptor. Histamine stimulates its receptor, cells through its receptor, and on and on. But then there's a different kind of molecule called a blocker or an antagonist, which fits into the same lock but doesn't do anything. You might picture it as putting a key into a lock and then it breaks off. So nothing happens, can't turn. But now the real key can't get in there because the passageway is blocked. That's what we call an antagonist. So for example, something that does that at a histamine receptor would be an antihistamine. Anyway, to make a long story short, over the decades, we learned more and more about the receptors. We particularly use something called the beta adrenergic receptor, which is one of several receptors for adrenaline, and eventually purified it and actually cloned its gene. And as shown in the lower panel of this slide on the left, we were able to show that had a very unusual architecture. Each of those little balls represents an amino acid residue in the protein of the beta adrenergic receptor. And you can see that it crisscrosses the cell membrane 7 times with loops in between. Well, that was very interesting. That was the first real receptor to ever be isolated and have its gene cloned. Over the next few years, we isolated and cloned about a dozen other receptors, and they all looked like this. And in fact, eventually, as you can see here, the family of these receptors, which crossed the plasma membrane 7 times, grew to encompass about 1,000 different receptors. And these receptors mediate not just the actions of adrenaline, histamine, serotonin, etc., but our sense of smell, our sense of taste, and even the way we see, our vision, through a molecule called rhodopsin. Now, the implications of this have been very, very striking. This is a basic research problem. It was never intended to cure a disease, develop a therapy, a new treatment, or a new drug. But as is so often the case basic research which unlocks whole new vistas of science often has very important therapeutic implications. In this case, it has led over the years to the development of many drugs. In fact, these receptors, and they're generally referred to as G protein coupled receptors, because these receptors signal to the inside of the cell through another protein called the G protein. So these receptors are often called G protein coupled receptors, or GPCRs for short. There are about 1,000 of them. Today, 1/3 of all FDA-approved drugs are drugs which target these receptors, either as agonists, like adrenaline, or as antagonists, such as antihistamines or beta blockers. So although it was very basic research, it had very widespread and important clinical and therapeutic ramifications. Now I want to talk about some of the fun things that happen to you when you win a Nobel Prize for your work. The first is that you meet a lot of very interesting people. So you can look at this slide that shows me and somebody next to me. I want you to think to yourself, can you recognize who that is sitting next to me? The answer is Tony Fauci, who is a very good friend of mine. You all know who Tony Fauci is. Tony and I were drafted into the United States Public Health Service at precisely the same time. We both went there in 1968, and we both left in 1970 at the completion of our 2-year term. However, unlike myself, Tony went back, and you know what he's been up to. I got to meet President Bush, as shown here, when I won the National Medal of Science. I got to meet the King of Sweden in 2012 when I won the Nobel Prize. I got to meet President Obama in 2012 as part of a long-standing tradition in which the President of the United States greets all the American Nobel laureates when they are on their way to Stockholm to get the prizes. You may not be surprised to learn that President Trump broke this tradition and never met with any of the Nobel laureates during his 4 years in office. And then I got to meet the famous Coach K, who announced this very afternoon that next season would be his last. So this is the winningest coach in basketball, men's basketball history. I received the call from Stockholm at 5 a.m. on October 10th, 2012, waking me and my wife up and informing us that I would receive the Nobel Prize in chemistry. And 2 days later, Coach K, who to that point was not, somebody that I knew, although I was a great admirer and a holder of season tickets for decades, he called me up and he said, "Bob, I'm so proud of you and so excited about your accomplishments." He says, "You know, I brought Duke our very, very first national sports championship. And now you've brought our university our very first Nobel Prize. So," he says, "I really feel a kind of kinship with you, and I'd like to bring you down to Cameron Indoor Stadium to be honored by the team and the fans." And so a week later, I went down there, and as you can see, standing at center court, they presented me with my own jersey with the number 1. The fans, as you can see in the background, the students at our relatively small stadium, it only seats about 9,000. The fans that sit the closest to the field are the students, and they were going crazy. Now, the Duke students are famous for chanting things, typically at opposing players, chanting in unison. And as I stood there, I could hear the students chanting something in unison and pointing at me like this and chanting. And I couldn't bring it into focus. But then all of a sudden, I could hear what they were saying. They were saying, "He's so smart. He's so smart." Well, obviously, that was a big thrill. And you can't see it here, but at that point, I threw my arms up in the air, and that was just terrific. So I've also had some other interesting experiences. One of the things that you often get a chance to do when you win a Nobel Prize is you're invited to throw out the first pitch at a baseball game. And so I was invited to several such things, but in particular, I was invited to throw out the first pitch at a game of our minor league baseball team in Durham called the Durham Bulls. There was a movie before all your time called Bull Durham about that team. In any case, they had a ceremony honoring me from left to right. That's Wool E. Bull, the team mascot, myself, Victor Zhao, with the object in his hand, was at that time the CEO of Duke Medical Center, and that's Mayor William Bell, Bill Bell, the mayor of Durham. I practiced very hard because I knew for 2 months that I would have this opportunity, and I didn't want to blow it. And the people in my lab kept sending me these terrible videos of people screwing up first pitches. You know, you can go online and just Google 10 worst first pitches ever, and you get these horrible things. Some of you may have seen Tony Fauci's first pitch, and that was pretty disastrous. Anyway, I practiced long and hard, and I really want to show you what the end result of that was. So watch closely, and you can see the Jumbotron there, and here I go striding out. Did you see that? I'm going to show it to you again in case you missed it. I want you to look where that ball lands, right in the breadbasket there. A perfect strike. Perfect strike. You may note that it was not going very fast. I told everybody that was my changeup. Here we go. Big windup. Look at it. Perfect. So when I was done, as is traditional, the catcher brought the ball out to me, put it into my mitt, looked me in the eye, and he said, "Doc, that was one hell of a throw." And I can assure you that was one of the proudest moments of my life. This is the last photo I'm going to show you of me with interesting people. I'll give you a minute to look at those retired or older rockers. See if you know who they are. That's Peter Gabriel on the left, Sting on the right. I don't know if you know who those guys are, but some of the other folks in the audience may. And you can see that they are kneeling before me in a sort of a charade of sort of worship, if you will. Now, if you're saying to yourself, what in the world is this about? How did this photograph come to be? If you want to find out, you're going to have to read my book. So you'll read the story there. Two last little things I want to tell you about before I wrap up. One of the most important things going forward in your careers is mentorship. You know, I often tell people that if something's really important, you can't look it up in a book. Somebody has to show it to you. That's what mentoring is all about. And in science and in medicine, much of what we learn comes not from studying books. We study the books to basically learn the language and the facts. But then taking care of patients, doing discovery research is a function of learning by example from mentors. And I want to show you a picture here, which I think makes the point of just how important mentoring is. Remarkably, this program at the NIH, in which Public Health Service officers staffed laboratories during the Vietnam War, led to the production of 10 future Nobel laureates. And they are shown here in this yellow band in these rectangles colored blue. For example, here's me. So all of these 10 Only 2 of them with any research experience before they went to the NIH. The rest of us, aspiring physicians with no prior research experience at all. We go there for 2 years, and then in the fullness of time, we wind up winning Nobel Prizes. This is a family tree, a genealogical tree, if you will, in which you can trace the mentors who basically trained each of these people. And many of us, most of us, have more than one mentor. And this goes back many generations, if you will, in the family tree. Again, every rectangle colored blue is a Nobel laureate. So you may notice that of the 10, 4 of us were directly mentored by a Nobel laureate. And for the other 6, including myself, you don't have to go back any further than a scientific grandparent, okay, to find a Nobel laureate. And if you go back further, some of the lineages are absolutely staggering in terms of how many Nobel laureates there are. Look at this one here. Boom, 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 to here, to here. The only one here who isn't a Nobel laureate is a guy named Earl Statman, a very, very famous biochemist. And he trained Ira Paston, who was my mentor, who in turn trained both myself and Varmus, 2 other Nobel laureates. So I show this, and again, Nobel laureates are just the very tip of the iceberg, but I show this simply to make the point that there are transferable elements in the process of doing very high-level science that can be taught by mentors. And I appeal to all of you as you go forward in your careers to choose your mentors very, very carefully. It's a much more important set of decisions than where you ultimately go to college or graduate or medical school. The actual individuals that you choose as your mentors, and you will have a lot to say about who your mentors are going to be. Those, in my view, are one of the most important sets of decisions you'll ever make. So I think this is the last slide I want to show you, a little lighthearted, but it is worth thinking about. So this is taken from an article in the New England Journal of Medicine, which ironically appeared on the very day that I got the call from Stockholm that I was receiving the Nobel Prize, which, as I told you, was October 10th, 2012. I did not learn of this article until maybe 6 months later. But what it purports to show, I suspect somewhat tongue-in-cheek, but these are data, is a plot of the chocolate consumption per capita in different countries versus the number of Nobel laureates, essentially per 10 million population. Each flag represents a country. And as you can see, there's a remarkable, seemingly linear correlation, highly statistically significant, between how much chocolate is eaten in a country and how many Nobel Prizes are won. The only outlier is actually Sweden, which has too many prizes relative to their chocolate consumption, immediately raising the question of whether they're cooking the books over there and showing favoritism towards their scientists. In any case, why do I bring this up? Well, I've been a devotee of dark chocolate pretty much all my adult life. And for years, I had eaten 1 or 2 squares of dark chocolate a couple of times a week. But true story, in the summer of 2012, I announced that, I'm doing very well. My weight is good. My cholesterol levels are good. I'm 69 years old already at that time. Why shouldn't I eat it more often? So I decided in the summer of 2012 to move from having some dark chocolate a couple or 3 times a week to having it every single night. 2 months later, I won the Nobel Prize. Now, I draw 2 conclusions from this. The first is that there's a dosage effect, and there's a threshold, which I had not actually exceeded until I went to daily ingestion. But the second is that it's obviously very rapidly acting because I was able to get that prize within 2 months of increasing the dose. So again, I recommend dark chocolate above 70% cocoa to you as a way of hastening your joining the ranks of Nobel laureates. Just want to recommend my new memoir, which has just come out. A funny thing happened on the way to Stockholm. I believe each of you finalists has received such a book. I recommend it to others in the audience as well. It's a lighthearted look, but also serious in parts, about a career in medicine and science. Also, if I've gotten you interested in the way things were in that program at the NIH that produced so many academic superstars and Nobel laureates, I also would recommend to you a four-part podcast that was narrated by Alan Alda, just came out this year, called Soldiers of Science. It shows pictures of several of us who were involved in that program as we looked in 1966. Here's Tony Fauci. Here's myself, several other future Nobel laureates here. Well, I've enjoyed chatting with you. I hope you've enjoyed listening to my stories. And that's all I've got for you this evening. I don't know whether we have time for questions or not, but hope you enjoyed.
We thank you so much. All right. Loved your tree of mentors. That is fascinating. And we have an RSI alum who is a researcher who would agree with you. Her research is on chocolate. All right.
Fantastic. That's wonderful.
Yes. Yes. So thank you so much for being with us. Appreciate it.
My pleasure.
Okay, the next thing we're going to do, I have the pleasure of announcing the 20 finalists. They come from all over the country. They've been here since virtually since May 22nd and worked, I would say, almost 24 hours a day on learning as much biology as they can and also having some fun along the way. So the first one that I'd like to introduce you to is Akshay Atleri. He's a junior from Cupertino High School in California.
Hey everyone, my name is Akshaya Taluri. I'm a junior from Cupertino High, like Ms. Frame mentioned. Here's my finalist certificate. And yeah, I've had a great time here and I'm really grateful for all you guys for coming to see us up.
Thank you, Akshay. Okay, next we have Sophia Chen, and she's a freshman from Sage Hill School in Newport Coast, California. Sophia.
Yeah, I just really like to thank you, USABO, for giving me this opportunity. Yeah.
Thank you. Next is Derek Chen. He's a junior from Belmont High School in Belmont, Washington. Derek.
Sorry, I'm not from Washington. I'm from Massachusetts, but yeah, USABO Finals has been such a great experience.
Thank you for correcting me.
Sorry that this might be mirrored.
That's good. That's good. Okay, the next one is Arthur Hugh, who's a junior from Lexington High School, I believe.
Yeah, it's been a great opportunity to be here this year. Here's my certificate.
Thank you, Arthur. Okay, next we have Jonathan Wong, who's a senior at Lynbrook. Jonathan. You're muted.
Oh, sorry, I must have been muted. Thank you very much for this opportunity. I thoroughly enjoyed the USABO program, and yeah.
Thank you, Jonathan. Rohan Ear, junior from Redmond, Washington.
Hello, I'm Rohan Iyer from Washington State. It's my certificate. And I've had a lot of fun meeting all the other finalists.
Yeah, and his brother, Kartik, was also a USABO finalist a couple of years ago. Next, we have Judson Lamb from Naperville North High School in Naperville, Illinois. Judson.
Hello, my name is Judson. Oh, I guess my thing is covering it. But here's my certificate. And as everyone mentioned before, I think USABO experience was really fun for me this year. So I'm happy that I could come.
Thank you. Next is Lawrence Long, a junior at Basis Independent Silicon Valley.
Sorry.
That's okay.
Hi, my name is Lawrence. Here's my certificate. And I definitely had a lot of fun this week and learned a bunch of bio.
Thank you. Now we have Peter Pooh from junior. He's the University of Chicago Laboratory Schools, Chicago.
Hey everyone, my name is Peter. I'm from Chicago, Illinois. not too far from Judson and like Grayson. And yeah, USABO camp has been cool, amazing people, and really cool TAs.
Thank you. Okay, Grayson Wren, a junior from Adelaide East Stevenson High School in Lincolnshire, Illinois.
Yeah, I'd just like to thank the CEE and the USABO program for such an amazing opportunity over the last week and a half.
Okay, next we have Albert Tam. He's a junior from Lynbrook High School in San Jose.
Hi, I'm Albert. I'd just like to thank the CEE and everyone here for camp. It's been some of the best 2 weeks of my life.
Oh, that's good to hear. Okay, next we welcome Alexander Tang. He's a junior at Lexington High School.
Hi, everyone. I'm Alex Tang. I'm very thankful for the USABO organization, the CE, TAs, and instructors for making this opportunity possible this year. Thank you.
Thank you. Lynn Tao is a sophomore from Thomas Jefferson School for Science and Technology in Alexandria, Virginia.
Hi everyone, my name is Lynn. I'm from Virginia and I have had the greatest time at USABO camp and I'm really thankful to be here. So thanks.
Thank you. Jason Wong, a freshman from Marriott's Ridge High School, Marriottsville, Maryland.
Hey everyone, I'm Jason. I'm from Maryland. Here's my certificate. I've had so much fun the past 2 weeks meeting all the finalists and getting to meet and talk to with all the other TAs.
Nicholas Way, a sophomore from the Harker School, San Jose, California.
Hello, I'm Nicholas. Here's my certificate. And I've had such a great time at USABO Finals Camp, and I hope we can all stay in touch.
That's the plan, Nicholas. Okay. Julianne Wu, freshman from University High School in Irvine, California.
I'm sorry. Here's my certificate. So, hi, my name is Julianne Wu. I'm from University High School in Southern California. I had lots of fun at the USABO program, and I'm really grateful that I was able to learn lots of biology from lots of amazing instructors and TAs and making a lot of new friends.
Thank you. Andrew Wu is a freshman from Marquette High School in Chesterfield, Missouri.
Hello, everyone. My name is Andrew Wu. I had a lot of fun here learning with everyone at the camp, and I had a very great time here. And here's my certificate.
Thank you, Andrew. Next is Albert Zong. He's a senior at North Hollywood High School in North Hollywood, California.
Everyone, my name is Albert Zhang. Here's my certificate. And I'm very grateful to USABO and CE for this great experience. And also many thanks to Dr. Lefkowitz for the wonderful talk.
Thank you. Next is Michael Zhao. He's a senior at Lynbrook High School, San Jose, California.
Hello, I'm Michael. I will try to trick Zoom into showing my certificate, but you know, after a year of remote learning, I'd have to say this is the best 300 hours I have spent.
Thank you, Michael. Next is Caleb Zhao. He is a sophomore at Montgomery Blair High School in Bethesda. Silver Spring, sorry, we had a little thing there earlier. Silver Spring, Maryland, excuse me.
No, you're good, you're good. Hi, I'm Caleb, and it's been an absolutely wonderful time here at USABO Finals. So I just want to thank everyone who was involved in this and making this such a great experience.
Yeah, and I was remiss, all right, when I introduced Akshay Atleri, all right. His sister, Nithya, all right, is a USABO alum as well, and has been very important in supporting both virtual finals that we've had. So acknowledge that as well. Next, we will have the presentations of medals, all right? And Dr. King will lead that.
Awesome, thank you so much, Kathy. First off, we want to congratulate every single one of you. You have completed an amazing accomplishment just getting this far. But it is my pleasure to introduce the 4 individuals who will be receiving the bronze medal. So our first bronze medalist is Caleb Zhao. Awesome. And our next bronze medalist is Michael Zhao. Our third bronze medalist is Joann Wu. And our last bronze medalist is Albert Tam. Congratulations, everyone. Okay, and now we will move on to the silver medalist. Yes. So our silver medalists are, oh gosh, sorry, the chat is jumping in the way, is Jason Wang. Our second 2021 USABO silver medalist is Peter Pu. And our third 2021 silver medalist is Jonathan Wong. And our final silver medalist for the 2021 USABO National Finals is Arthur Hu. Congratulations, everybody, on receiving your silver medal. Congratulations. And now we will move on to the gold medals. And these 4 individuals will represent our country at the International Biology Olympiad as Team USA Biolympiad. Let's get this all going. Okay, I hope everyone is doing a drum roll in their head, because I am. So the first recipient of the gold medal is Albert Zhang.
Thank you very much. Very honored.
The second recipient of the gold medal is Grayson Wren. Congratulations. Our third recipient of the gold medal is Judson Lamb. Congratulations, Judson. And our final recipient of the gold medal and to complete our team to represent us at the IBO is Derek Chen. Congratulations, everyone.
My congratulations to you all as well. All right. Thank you. Thank you. Now we just want to do a little bit of acknowledgement of all the people that helped us get here. Among those is the staff, the CE staff, and all their support of us. Joann DiGennaro, particularly, all right, and her support of the USABO since 2002, all right, when she actually said we would have that in the United States. So we are very appreciative of her and all of her staff. And right now I'd like to highlight the TAs that are here who have done an enormous job, as all the finalists will tell you, all right? They've been working since March and April, all right? And then more than 24/7, all right, throughout this time and prior to this, all right? The ones we have here, I believe we have Artharv is with us. Thank you, Artharv. Okay, we have Bob Zhang.
Thank you so much, everybody.
Next, we have Henry Shen, sorry. He was here earlier, so he may have had to leave. All right, Lakshay Sood.
Hi, everyone. Thank you so much for having me here. I really appreciate this opportunity.
Thank you. Next is Chris Wong.
Hi, everyone. It was a blast this year to be a TA for you all. It was exhausting, but it was a blast. So yeah, rock on.
Yep. Next we have Jason Song.
Hey, congrats everyone.
They all look so rested and they can't possibly be rested. They have put in so much work. And last is not least is Lucy Zhao, who helped us as well.
Yay, congrats everyone and good luck with everything in your future.
Yeah. Thank you everyone. All right. Now the 2021 national finalists selected someone they wanted to represent them and their experience here at national finals. And the person they selected is valedictorian of his class. He's president of the student body, and he had 4 of those ceremonies to attend, 4 sets of them for his school, Lynbrook High. All right, so we're expecting wonderful things, and he's been wonderful. He's absolutely amazing. He was with us last year as well, and it's Michael Zhao. Michael.
Thank you, Ms. Frame. Friends, family, lecturers, TAs, CE staff, Ms. Frame, Dr. King, President DiGennaro, Dr. Lefkowitz, and further distinguished guests, thank you so much for coming to the 2021 USA Biolympiad closing ceremony today. It's an honor to speak to you on behalf of my wonderful fellow campers, and I just wanted to mention that today is the culmination of 12 days of intense biology study. But more than that, today is the culmination of 12 days of amazing fun and budding, lasting friendships brought together closer by the wonderful experience CEE has provided us here. You know, I've learned all about turtles from Dr. Stearns. I've taken a virtual tour of the Missouri Botanical Garden, and these past few weeks have provided more than I could have ever expected from a virtual experience. Thanks to the hard work of our lecturers, TAs, and of course the wonderful Ms. Frame and Dr. King, my fellow campers and I were able to have a fulfilling, exhilarating experience here at camp. And I often think about how amazing it is that I've been able to meet 19 other budding scientists who are just as passionate about biology and tackling the problems of the future as I am, and just how grateful I am to the USA Biolympiad for making this possible. Through working with my fellow campers who are from across the nation, I've learned firsthand the value and even the necessity of collaboration in tackling the toughest problems on the PSET. Sitting at study sessions, you know, maybe I can't solve the problem myself, but by working together with Albert or with Julianne, with advice from Akshay, we can make progress together. And I'm confident these skills that we've learned at camp will stay with us and will help us as our generation tackles the world's most complicated problems of the future together. Each part of this program was really exceptional, and it's hard for me to single out individual sections I want to talk about, but you know, I especially enjoyed the eye-opening presentations we were so fortunate to get from research and industry leaders. I can think of no other program that gives high school students such vast opportunity to ask these amazing professionals one-on-one about everything from their research to general life advice. Just as wonderful, I think, was this year's Meet the USA Biology Olympiad finalists event with past alumni. I can personally attest that the USA Biolympiad Alumni Network is as strong and as vibrant as ever. I've kept close friends with last year's campers at the first camp I was grateful enough to attend, and I'm looking forward to keeping in touch with all of my fellow campers this year as well. I even personally reached out to past USA Biolympiad alumni for college advice as I finalized my college decision this past spring. And I think this just goes to show, like Dr. Lefkowitz mentioned in today's keynote, the importance of mentorship and how CE's ability to connect us with mentors, with alumni, with people that are involved in CE, this has been truly priceless. And the opportunities that USA Biolympiad provide us are endless and bountiful. And that to me represents everything that USABO stands for, this bounty of opportunity. So as I prepare to graduate from high school, I think of Sir Winston Churchill's quote that this is not the end. This is not even the beginning of the end, but perhaps this is the end of the beginning. Though I just graduated from high school and I will no longer be able to participate in the USA Biolympiad, unfortunately, I know that the opportunities it's provided, the experiences that I've had here, the doors the Biolympiad has opened, will continue to shape my future. I'm proud to have participated in such a wonderful experience here and prouder yet to join USABO's strong alumni community and continue to give back in the future. The USA Biolympiad has really truly been a once in a lifetime experience and one that I will always treasure. This competition has enriched the lives of me, my fellow campers, and thousands of high school students across America. So for these cumulative 550 hours over my past 2 years of camp, and for everything USA Biolympiad has done and will continue to do, I am eternally grateful. Thank you.
We thank you, Michael. All right. And Dr. Lefkowitz, I think you're going to see some of these people in your tree, all right, your genetic tree in the days to come. So we thank everyone that was here to share this. I see there are actually some alums that are in the audience as well. So thank you for coming and supporting our newest USABO alums who will be part of the Rickoid and the CEE family. All right, and so we say good night to each of you and congratulations to all the finalists. Right, good night.